loose of that without sending in some information to me about his thoughts. So he's participating from afar. Hopefully he may be listening right now as well too. So those of you that know Mike Albrow, he was a physicist at Fermilab here for a number of years and moved over and did a lot of physicist work at CERN, was involved quite a lot with activities there and with the church and with acting and singing in the area. So kind of a Renaissance man in a lot of ways. And he's actually moved to Reston, Virginia, those of you that don't know that. And he's implemented, and I haven't heard too much about the success or whatever of it, but he's been excited, and he's started Science Sunday out there at a UU church there too. So it's kind of our godson is out there doing that or whatever. So he was saying a message to me I thought I'd read. Dear all, greetings from Reston, Virginia. Sorry to miss your important inventions on Sunday, but my vote is in this piece that was in Positively Naperville in September of 2021. He wrote an article, a monthly article for the Naperville community paper, and he called it Positively Naperville, and he usually talked about scientific items or so. So 1821, he wrote it then 200 years later, right? 1821, the most important event, and this appeared in the September 2021 Naperville community paper. In 1821, 200 years ago, history books tell of Spain granting Mexico independence and ceding Florida to the U.S., but perhaps the most important event was the moment on September 3rd, 1821, when 30-year-old Michael Faraday watched a metal rod move in a circle around a magnet, powered by an electric current from a battery. Imagine his excitement. He was the first to see the conversion of electrical energy into mechanical energy, an electric motor. Later, he made it work the other way, a dynamo turning mechanical energy into an electric circuit, into electric current. Where would we be without those inventions, made in the basement of the Royal Institution in London? Prime Minister Margaret Thatcher said to the Royal Society, "The value of Faraday's work today must be higher than the capitalization of all the shares on the stock exchange." She had a bust of Faraday in 10 Downing Street. Faraday left school at age 14 to be an apprentice bookbinder. He educated himself with books that came his way and attended public lectures by Humphrey Davy, the director of the Royal Institution. He wrote up Davy's lecture notes, bound them in a 300-page book, and presented them to Davy, who made him an assistant, knowing a hard worker when he saw one, I guess. Knowing little mathematics, but having boundless curiosity and practical gifts, Faraday became the greatest experimental physicist of the 19th century. In 1821, others were experimenting with magnets and electricity, which seemed to have a mysterious connection, and an electric motor would have been invented anyway. But Faraday was ahead of others and prolific in fields other than electromagnetism. That word did not exist before his experiments. Mike says, "I recently visited the Royal Institution basement and saw Faraday's laboratory and equipment. Not replicas, the real things. How cool is that?" So in 1825, he started the Royal Institution Christmas lectures for children, which you may have seen. You can see them on video, on YouTube and so on. Dawkins did them for quite a while as well. For children in the school holidays. They continue to this day. Mike says, "I was lucky enough to attend as a teenager in 1959, sitting in the same lecture theater where 100 years earlier Faraday gave lectures called The Various Forces of Matter and Their Relations to Each Other. The same title could be used today, adding the nuclear forces to Faraday's electricity, magnetism, and also gravity. Based on Faraday's work, James Clerk Maxwell explained light and other electromagnetic waves. Faraday and later Einstein tried to unify electromagnetism and gravity. Would a grand united theory of all forces have had such a great impact on civilization? Who can tell?" So, he says, "P.S. This is one of 100 short stories about the universe shortly to be published by Fulton Books. I plan to be near Chicago on Sunday, February 2nd, and if you like, I could give a presentation on new astronomies, cosmic rays, neutrinos, and gravitational waves, and promote my book. maybe even sell a couple. Best, Mike Albrow. So Mike's going to be here. Scott and I immediately jumped on that horse, you know. So he's going to be here as far as we can tell, unless incidences occur that change that possibility. But he's going to be here February 2nd, which is just about a month from now, right? 4 weeks from now. So get your questions for Mike, because I'm sure he'll love to talk about it with you. I know there's some physics-based people in the audience right here, and so come in with your thoughts and ideas and listen to him talk. So I thought that was very pleasant to hear from Mike. So if anybody needs or wants to get in contact with him, both Scott and I have his emails and ways to communicate and so on too. So that was nice to hear. I wanted to talk, and I gave an example. Who remembers the example I gave for what was an impactful invention? When I sent out something in letters, I said infant formula, which I thought maybe is an interesting thing to talk about. I'm trying to not, there's a concept of very concrete inventions and things that could be implemented and talked about here, and I hope we get into quite a few of them. But I also wanted to get into some, and that baby formula is an impactful thing, but it also has some soft ideas about it, like how it came about and why it came about and so on too. So and it all started, you may not know this, but infant formula started with an immense volcano in Mount Tambora in 1803. It was such an immense volcano that it lost 4,000 feet of Mount Tambora when it was finally done. You may have heard other things about it. The noise from it was so loud that 500 miles away, Navy captains of Her Majesty's fleet, His Majesty's fleet at the time, got their boats all ready and they sailed out to try to find it. They thought it must have been on an island, 100 miles away or 50 miles away. They heard cannon fire and they went to find where it was. But it was an enormous, enormous explosion. And because of that enormous explosion, ash, first things went downhill from lava and toxic gases fled downhill at hurricane speed, killed thousands of people, right? But also the volcanic ash that came up into the atmosphere traveled quickly around the whole, mainly the northern hemisphere. And it was, that was in 1813, right, 1813. And that next year, I'm off by a year there, but I need to have the clicker too. I didn't bother to come up here and get the clicker. But that next year was called the Year Without the Summer in Europe. Have you heard about the Year Without a Summer? Okay, and it was such immense degradation of the atmosphere, and sunlight couldn't get through, and basically plants didn't grow, right? There was very little there. So if we start to talk about infant formula, we have to talk about man that was impacted by what went on there. And this man was about a 10-year-old kid when he saw what was going on here, maybe 12 years old. Justus von Liebig, born 1803 in Darmstadt, Germany. And there's a statue to him in Berlin that is standing yet. And he was really impacted. He was, I think, 13. I get the dates here. 1816 was the year without a summer. Crop failure. Desperate people ate rats and cats and grass, not glass. But as a chemistry professor, he was born in 1803, like I say, and he saw a lot of terrible issues going on. It very much affected him. And he decided, he got very interested in chemistry and food sources, all this. He was devising modern laboratory teaching techniques, is what he was known for. Something jumped there. And he was known, he did a lot of scientific research into fertilizers, and he pioneered nutritional science. He was trying to find ways that people could get past this starving that he saw so rampant throughout all of Germany. It's a pretty impactful thing to see when you're 12, 13 years old, to see people starving and having no source of food for a year. So he devised methods of cookery, and he developed beef extract. At the time, it was thought that you just basically needed to get protein, and the more meat you ate, the better it was for your health and so on. But he was understanding that the juices that were in meat were very important to your health, right? That the chemicals and the nutrients that were in the meat. So he talked about saving the nutrient. In those days, people would just boil stuff and then throw out the water, right, that had all these nutrients in it and get rid of it. And he brought up this beef extract idea, the concepts of cookery. He brought up the concept of searing the outside of beef. If any of you do that, how many people sear the outside of a piece of meat before? Yeah. The value of that is it keeps the juices and the nutrients inside. And he's the man that developed that concept. So a lot of this was, and he talks in his writings about how affected he was by seeing the starvation that went on in Europe at the time, and the poverty that ensued from that. So he wanted to make discoveries that might prevent hunger. And he was looking at, because when women were starving and they had babies, they weren't able to provide many nutrients to their new babies either, right? So he had this whole emphasis of finding ways to get that. And it's still known what his formula was. He used cow milk, some malt and wheat flour, and potassium bicarbonate. You may have heard of sodium bicarbonate. That's baking soda, right? And this does the same thing. It provides some effervescence, some lightness to a thing. Potassium bicarbonate adds CO2 to make things like bread rise and things like that too. So that was his, if you ever want to try to reinvent Liebig's soluble food for babies, but he came out with it in 1865, and his emphasis was an invention to try to help hunger and help babies that were not able to live on the breast milk that was there or not available for them. Okay. It was the first commercial substitute for breast milk based on scientific study. There were other earlier solutions for that. A lot of times, poor women would give what they call pap, which was like milk and flour soaked in, a rag soaked in milk and flour and water, and then the baby would, suck off the rag or things like that. But there are some values to this right now. This is the first time they started to understand a little bit more about germs. In the late 1800s, they were understanding germ theory a little bit more, and they first came out with the actual rubber teat that could imitate a nipple. And so there were some valuable things. And if we talk about the value of what he did, he felt like he was maybe going to save hundreds and hundreds of thousands of babies, right? But now, what's the downside of infant formula and all that? It didn't do everything he thought it would do, right? First of all, it's like it's a do it and it's done thing. There, once you wean a baby off of breast milk and the mother's dries up, then you're committed to giving infant formula to a baby, right? And the problems with infant formula are the fact of maybe health in some ways. Which formula had hundreds of million years to develop to provide the best nutrition for a baby? Liebig's solution or human breast milk? I mean, it's hundreds and hundreds of millions of years. They're finding out more and more every day. There's supposedly some level of reaction that a baby will get its saliva back as it's nursing, and that saliva influences the creation of the further amounts of breast milk. There's different breast milk that comes out in the morning and at night and different times, that provide what's at least the best way that evolution can devise a solution for how to best feed a baby, right? Anyone have an idea of another problem with infant formula compared to breast milk? Allergy to cow's milk. Cow's milk is not as easily digestible.
Quality of the water that you're mixing.
Exactly, yeah. A big thing is the impurity, right, the quality of the water that you're mixing it with. So people are mixing this in a lot of different situations. To many of us in Naperville, Wheaton, the western suburbs, that's not considered to be a big problem. It doesn't generally come about. But it's true that in a lot of this is bought and sold and so on in African countries, right? Where maybe there's a lot of women that see it as a convenient kind of thing, right? And they buy it, and then they go dry, and then they are tied into this use of this, and who knows how easy it is to acquire water in these places, right? Sometimes, Dave, when you were in Africa in the Peace Corps, there were some large trips to get water, weren't there, by people? Or?
In some places.
Yeah.
Unsafe water. More eating of porridge rather than proper formula.
So they'd give babies what their best imitation of formula might be.
Sorghum porridge.
Right, so sorghum porridge, Dave is saying that they would often give to people, and it maybe looked like breast milk, and it was their closest approximation to breast milk, but didn't have any of the qualities, or didn't have many of the qualities that actual human breast milk had. The values of breast milk, people use it nowadays, obviously. People use infant formula and the values of that, and it's changed the world. That's what I wanted to kind of talk about too, shaping the modern economy. Once you can feed and have infant formula available for a child, that gives freedom to some extent to the mother to stay in the workforce, right? To go travel, to not be tied in as much to motherhood, right? And can still provide for their child, but not provide by being constantly there and on demand and so on too. So there's a value to that, but it's definitely changed the world in a lot of ways, and there's some good and some bad about it. So anyways, that's kind of my topic. I wanted to see if we had potentials, and I think Scott has a microphone, and I asked people to kind of think of, I didn't want to start out with something that everybody would say, yeah, that's the invention. I wanted to have opportunity for everyone to come up with some thoughts, and I didn't think many people would think of breast milk, so I came up with that. Ray has one right up here. Let's get a microphone.
Since I have the microphone, I was going to say a washing machine also affected economics hugely and made women available for other tasks other than one of the most onerous household tasks.
Can we talk about that for a minute?
All right.
Before we get to Ray's? And there's some thoughts about, there are a lot of labor-saving devices, but sometimes labor-saving devices have not that much impact on saving labor. And in terms of the washing machine, I think that when you have a washing machine, people throw clothes in the washing machine that are pretty clean yet, right? When you had to wash them by hand and scrub them on a thing and, get the soap and shave it all up and do all this stuff, people would wear clothes for, sometimes I know they talked about people being sewn into their long johns for the winter, which is why they had the flaps maybe. But actually, it didn't make us less work in some ways, as it made us smell better,
There's benefits to that.
There are benefits to smelling better. There are downsides sometimes too, but it means everyone will spend time with you, right? You don't get your solitude as much. You don't get to do your quiet study by yourself.
Your alone space.
Right. So, there are talks about a lot of these labor-saving devices and how they're marketed and sold that way, right? Mix masters or this or that. But people, they say that there's as much time spent now cleaning clothes and folding them and ironing, doing all these different things as there were many years ago, hundreds of years ago. Just a thought. And not to shoot you out of the water or anything like that. And I'm not going to jump on everybody's ideas here, but
No, I think you should.
when I can jump on your ideas, that's kind of fun.
That's fine. I need humility.
Yeah, I was going to mention GPS because it is an example of a practical application of special relativity and general relativity.
Right, yeah. positioning systems, GPS, how we can know where we are. It used to be when you had a party, you had to send out a map to tell everybody where you lived, and people got confused and everything. But yeah, just the positioning systems and how it used higher level maths, special relativity, and all these different aspects. I mean, just the fact of getting satellites up in the sky that we can know where they are so accurately that these satellites can then triple position or quintuple position us to bring it to yards. And still, they're still accurate nowadays to within maybe three yards or something like that, which is why when you see all these driverless vehicles, they don't just have GPS associated with them, they have sensors as well too, because 3 yards will get you down a highway as long as no one else is going on it. But it won't keep you in that right lane, it'll cause a head-on accident. It's not accurate enough to stop those yet, is my understanding of it. That they still have errors of accuracy in terms of that. So when you see these vehicles, has anyone ridden in a driverless vehicle yet? Have you? In San Francisco, John? Yep. Yeah. And Bob? Yeah, just this last week. How did it feel? It was great. It was great, huh? What do you think, John?
It wasn't bad at all, other than taking some strange routes. The turn is right here, it goes another block and then turns, but, I got home.
Yeah. I know, I read an article, and sometimes it seems like they say in San Francisco it starts, people want to mess with them a little bit to see what they'll do, so sometimes people walk in front of them and don't leave, so there you are in a driverless car, and somebody's standing in front of you, and the driverless car waits until that person leaves, because that's all it knows what to do. There was an article in the Washington Post that talked about women being a little bit nervous in it, because people could mess with it. People would be up rapping on the window or things like that, and you couldn't tell it what to do. A few times people were being followed, but it was still geared into driving you all the way home, which is not maybe what you want to do if you know that somebody's following you.
So if somebody stands in front of it, they could probably add a module that would just cuss out the person that's being an obstruction.
Well, they count on the passenger to do that. But yeah, GPS, I mean, I know my brother was a pilot of boats up in Alaska, and he was all on this LORAN and all these different things that were not as accurate, obviously, as GPS, and the means to get around now that there's GPS is just immense, right? Just fantastic.
Help ship traffic probably more than you and your car.
Right, yeah.
All right, ready to move on?
Yeah.
I had a completely different take on it. I was looking at the technology, not modern technology, but where everything began. And my thought was the inclined plane. It exists, but until we began to think about it and use it, it just was a force of nature. But then we found an inclined plane that we could use as a stone, so we could cut hide, and then make an arrow and get game, and then an axe, which we could cut trees. And of course that progresses to the ramp, so you can get things up and down more easily. And then we put steps into the ramp so that we now have stairways. And if we look at everything, every machine that's ever been built, without the inclined plane, we don't have screws.
Exactly.
You can't put things together.
You wind an inclined plane around a cylinder, and you get a screw that has
so you have
immense
a screw
holding
and
power.
a nut and on the other end. And also you think about the moving water and that kind of thing. So you have a screw that's moving water and also air and that
Archimedes pump.
Archimedes pump, yeah, is used today constantly in our present day dams. We use the Archimedes principle. So something just really, really, really simple to begin with makes civilization possible.
Yeah. No, and the impact that it's had to continue that is just phenomenal, yeah.
comment on your GPS. If anybody's interested, there's a show on, either on YouTube or Netflix somewhere, how this whole GPS started. And it all started with Sputnik. But you'll have to watch that. But the penicillin is what I thought. 1928, penicillin was kind of purified. Before that, if you get a scratch on your finger, you could die.
Yeah, there was a Civil War general. He won the battle at Shiloh, one of the first battles in the war, and he got a scratch getting into his rowboat at the end of the battle and died within a few weeks after that. Yeah, or something. Yeah, yeah.
I was thinking about something even more basic, and that's the invention of fire.
Fire, right.
And then associated with that is the ability to communicate, talk, and write. Because once somebody figured out how to start a fire, they had to tell others so they could use it, or otherwise it would go nowhere. So, you know, I kind of went back to the beginning to see, because they even assumed that fire was necessary for meats to be prepared. Well, first of all, you didn't eat contaminated meat. You could fire it and actually help the brain develop as part of it. So that's, if you go back to the very beginning, that would be something.
Probably human ancestors did that.
Right, yeah, right, exactly, even prior to you know, actually humans as we know them today. So.
Yeah, I was thinking of, the whole cooking hypothesis that Nancy Fleming talked about years ago at a Science Sunday, and the fact that humans developed this means of getting nutrition into their system without having to spend so much energy to digest it. You know, some of these there's a ruminant monkey that just eats all day and rests all day, which sounds appealing around this time of year, but or maybe we ape that, you know, but but actually the effort that it takes, the energy it takes to produce that, and then the amount of defecation that has to come out at the end of it too, to just process all that. And this cooking hypothesis basically says when humans developed the capacity in learning about cooking, similar to what Liebig was coming up with, that it just made living so much easier. You could put your energy into other things as well too. Yeah. Yeah, I think.
Well,
Rep-
she might have you have a comment about the fire?
Okay.
I had heard, and I don't know if it's true or not, that if we did not cook food, we would starve.
You mean humans nowadays? Because obviously we evolved from people, but our evolution has changed us in ways. Are you saying physically or like intellectually we wouldn't know how to?
In order for us to process starches and that kind of thing, we have to break them down. In order for us to process starches and things like that, we have to break them down. And so we cook rice, we cook potatoes, we cook yams, we do all those kinds of things, just boiling water, and that worked fine. If you had to eat them raw, and that's the only thing you had was raw meats, raw fish, raw everything, you'd starve because we don't have the internal systems anymore to do it. We have a relatively short intestine, and we take full advantage of cooking.
Mm-hmm.
And now, of course, on farms, we cook food for the cows, and we found that by cooking food for cows, we can use about half as much, and the cows still get terribly fat, and that kind of thing. So it works for all of us. But that, in turn, with a cow, that would shorten its digestion, and then what happens with that evolutionary? So we've evolved to the point where if we don't cook food, we have a problem.
Huh, that's interesting,
Yeah,
yeah.
I think I've heard that also. We have very short intestines and, yeah. All right,
Another thing that we've done is, long time ago, they discovered lenses so that they could use it, microscopes and telescopes, eyeglasses, and that probably led to discovering germs and penicillin and
Yeah.
all kinds of stuff in the medical field.
Just the intellectual knowledge gained by having lensing that can show us more about our outer world out in space, or our micro world and germs and things in there. Yeah, how could we understand germs without developing the lenses that allow us to look into that? I just got new glasses yesterday, and I'm seeing the world in a whole new light.
They're quite fetching.
I should have gotten rosy-colored glasses, but
I know some people that go through life with poop-colored glasses.
oh yeah. They have what do they call it? The outlook on life. That's
The opposite of rosy, yeah.
yeah, optoanal look
Yeah,
on life
right,
or
yeah.
something.
Somebody else have a suggestion for an invention? Printing press.
Gutenberg's printing press, and actually, that was preceded by only about 20 years in Europe by paper. Paper had been in China for a long time, but we used parchment, right? The Europeans used parchment, and which limited, the cost was to write the whole Bible. It takes something like 2,500 sheep or whatever to make the skins to be able to put a copy of the Bible out, and just the size of it and everything. But once paper came, and then the development and the concepts of paper, too, how paper is made, and it was originally made by cutting up rags, right? And the development of paper was a very permanent type of structure, and that was too costly and too inefficient, and the development of paper to be more of a thing that we can use nowadays, where we just print stuff out and throw it away or whatever, too, is an amazing thing.
Although we lost one of the benefits of vellum, and that is pomposets, so that they would scrape off the ink and reuse it. And with modern technology, we've been able to recover the text of much older books that may not have otherwise been copied or known. And that's because they reused the skin-based paper. And we can, with infrared technology and whatnot, we can read things that would have otherwise been lost and thrown away.
Which a lot of those were ancient Greek texts that were written and then destroyed by monks and so on to write more Christian-based texts on them too. So, yeah. How many people have read The Swerve? Have you read The Swerve? Fantastic book talking about a monk that went around to all the monasteries and places in Europe looking for old copies of things. He found things written by Greeks that hadn't been used yet. They're in a storeroom ready to be scraped off and used for writing other things, but they were collected from Italy and so on when the Romans had written these and collected the Greek works, and they were there and available, and he would find them and cash in. It's a great book if you haven't read it.
One of the other books I read that sort of builds on that same topic is talk about discoveries. The discovery of the New World, the Americas, may have launched, been a critical spark for the launch of the scientific revolution and the Enlightenment. Because prior to that, monks like Paggio, who would go around looking for ancient manuscripts, that was the way that you learned about the world, is you presumed that the ancient people knew everything about the world and how it worked. And the Bible says there's nothing new under the sun. And so people operated in what was called scholasticism. Their approach to learning and knowledge was to mine the past for knowledge. Well, suddenly when the New World was discovered, they learned that the ancients didn't know everything. There were things that were never recorded, never even imagined. New animal species and plants and lands and peoples, and that caused a firestorm of skepticism and discovery that led in short order to the scientific revolution. So the Paggio's quest to dig up old knowledge sort of was a stepping stone towards the invention of knowledge and discovery.
Yeah. I think there are some in back there, Dave.
I have to put in a plug for civil engineering.
Civil engineering.
Sanitary sewers. So when I went to Paris a few years ago, I had the extreme joy of visiting the sewer museum. And you can go down and see the first sewer in Europe. which saved Paris. And this year I also visited the oldest North American sewer in Montreal, which was instrumental in saving their downtown. Disease was running rampant. Businesses, people didn't want to be down there, and it transformed the cities, saved the cities. And now it's just, you flush it, it's gone.
Another one is, we talked GPS, but transistors. It's just amazing what's happened from the invention of transistors, semiconductors, into computers, the GPS, just that quick advancement we're seeing, where it took, as the previous example, it took us probably millennia to come up with fire, taking the transistor and the way it's made changes in society.
A lot of us can remember the ways of listening to radio with the tubes, right? And the tubes would be glowing, and your parents could always tell if you were listening to the radio at night because the room was glowing. But yeah, civil engineering, I think, is a fascinating topic about it as well, too. Just, I was reading some of that, and it actually, the Thames in London was just a cesspool. Things were there, and it was the city's complete disposal. Everything was just thrown in gutters that ran down to the Thames. And actually, they credit that one of the best reasons, usually things take 50 years to go through understanding and approval by governmental forces, sometimes it seems like, but by luck, the governmental offices are right along the Thames, right? And actually, it was once they understood what was going on, there's descriptions of it. They're just terrible, around where water kind of bubbled up around the pylons of the Tower Bridge and stuff like that. You could just look and see, terrible stuff in the water just boiling up all the time. But once it was understood, it was a matter of something like 4 or 6 years before the governmental people voted to clean up the Thames and to start putting in sewer systems in London. I don't know the date of that. Do you know the dates of what went on in Paris at all much?
I think it was the early 1700s, but the courage, the gumption, the gall, just to say, we're going to put in this huge pipe, displace people, people are going to get hurt and killed in installing this. It just as a civil work and a government project, it's quite amazing to read about those things. And same thing in London.
And obviously, it was a big topic in Victor Hugo's writing in terms of what went on in the sewers of Paris at the time and things, which was what, that was about 1760 or so. It was supposed to, the first part of Les Miserables is about. Yeah.
Did you have something?
The invention of the scientific method, one of the earlier works of René Descartes, Discourse on the Method, and others following.
Yeah, just that development of a means of how to solve a problem, right? How to look at things and how to set up procedures that would help you investigate and come up with a solution to things. Yeah.
What about the internet? Right?
Yeah.
You can learn nearly anything from the comfort of your own home. You don't have the arduous trip to the library. You can avoid that. You can avoid going to school for many things. I'm largely an autodidact, and I suspect most of you are too, and a lot of that has come as a benefit of having access to the world of knowledge.
Mm-hmm. Yeah. I had another one I thought I'd bring up here as well, too. Clocks and time telling. We had a whole discussion of John Harrison and his development of a nautical timekeeper. This is his first one, called H1. And in the 1700s, the British government put out a reward for anyone who could develop a way to determine the longitude, right? The only way to really determine where you are on a round surface is where you are compared to some standard. In the even though this was out in 1770, in the 1830s, I believe it was, clocks in Exeter, England, the western part of England, they added another minute hand to their clock. And you can wonder, there was a minute hand and then there was another minute hand. There was 14 minutes different from it. And when they were all these small towns in England, right, that all lived pretty much by themselves, it didn't matter if you were going to go to church and the church started at 10 o'clock, everybody knew when it was 10 o'clock, and the church steeple had a clock that said 10 o'clock and so on. But then when they started developing intercommunication between these cities, when there were trains that were built that were going, if you have, it would be noon, and the way it was in Exeter, England, was it was noon 14 minutes earlier than it was, 14 minutes later than it was, they were in Western England, and 14 minutes later than it was noon in London, right? So you start, and they called it railroad time. So one was the real time when you'd go to church, but the other one was when the train was going to come through and when you didn't want to be on the tracks or something, right? And it was going to be much more complication in terms of how do you schedule railroads that are going to go, and people would know to be at the railroad at noon railroad time, right? Not noon Exeter time. And the whole development of knowing where you are east and west of the longitudinal mark of 0, which was then standardized for this same purpose as Greenwich, England. So if you're on a boat that can't keep pendulums swinging accurately and precisely and so on, that's not a thing. Timekeeping and clocks were developed. Romans had water clocks and candle clocks and things like that, but they were accurate to within 15 minutes a day, maybe something like that. This got it down to about 15 seconds a day, and his other ones were even more accurate. And that's going on a boat, rocking back and forth and everything there too. Nowadays, they have cesium clocks, and a newer one, the cesium clock, his picture is here, accurate to plus or minus a second in 300 million years. I think what they're doing is they're measuring the droppage of some of these atoms under supercooled conditions and then getting it back up again. I don't really understand how they're doing it. And now there's a one, I don't know how to pronounce it, YTTER?
Yttrium?
Yttrium?
Yeah.
Yttrium clocks that are supposed to be to within a second or two by the time the sun turns into a red giant and eats us all up. So we'll know what time that happens when it does.
Interestingly enough, those clocks, somebody mentioned relativity. Those super accurate new clocks are being used to test consequences of the theory of relativity, both special and general relativity. And there's talk of using them to detect gravity waves also, because gravity waves cause a difference in place to place in our measurement of space and distances, space and time duration. So a super accurate clock can do more than just tell the time. It can help you map out the laws of nature.
And that's kind of what I wanted to see too when I started talking about infant formula, saying there's good things and bad things about it, and maybe a lot of these things we can say there's good things or bad. But what's the purpose of such an accurate clock? And you detailed one, and some of the purposes are, for example, I think they a few years ago they relayed cable, laser lines, optical lines through. They cut through mountains between here and New York, and it meant that because it didn't travel over and above and over and so on, these currents, this message would travel something like 3 milliseconds faster. Imagine the work to tunnel through all these mountains to lay fiber cable or optic cable that makes something go 3 milliseconds faster. And the only real benefit of it is that if you don't do it, somebody can trade something in New York 3 milliseconds faster than you, right, in Chicago, and all of a sudden they get the benefits. All this trading matters, this 3 milliseconds, who gets the potential to trade at what rates and so on too. So some of these things you say, imagine the money, when we're spending, money to do that, we as a society, when we also say it'd be nice to spend some money on starving people, more people having breast milk in America that need it, or infant formula or anything like that too. But, you know, what do we do about hunger, and what do we do about housing, and what do we do about these things? But we got to lay a line that gets us 3 milliseconds faster communication between Chicago and New York City.
You remind me of inventions of purely human artifacts, like interest on loans, or
Right.
fractional reserve banking,
Right.
or the corporation. Right? None of these things are natural phenomena in the universe, but they're highly beneficial to the pursuit of happiness and standards of living.
Say
I was
that-
thinking, you were talking earlier about GPS, and of course, we have to actually take into account, again, Einstein's relativity in order to know where the satellite is and where it is, and to begin to determine where physically things are. So again, accurate clocks are critical.
Yeah, the accuracy, and I don't know to what level, and if, I don't think that they're using the yttrium clock to make sure all our GPS work. I mean, so some are not, some are on different paths too, right? How accurate of a measurement do they use? There's pretty accurate measurements. They'll get affected if a technician walks into the room that they're kept in with the heat that the technician brings in with them. So, you know, they're very able to be impacted. I don't know how they maintain them without walking in the room, but there's some levels of you know, accuracy there that sometimes small minor things can change it so much. So I don't know to what level the cesium clock here or the yttrium clock actually are used in GPS systems. If anyone knows, that'd be interesting.
No, I don't.
Go
I
ahead.
did want to mention, Scott mentioned the internet. So I just wanted to bring up DARPA. This is a government agency that was in fact responsible for developing the internet. Also, the World Wide Web was developed at CERN. They did more than just find Higgs. They also developed the World Wide Web.
Yeah, there's a interesting, some of these very technical, very accurate, very important improvements are really sponsored or fed off the smartphones, right? We didn't talk about, you know, smartphones as an invention, but so many of the things in here are so dependent upon government initial development of these topics. The Army, the military, a lot of different fields of the government got into there and basically handed over the policies to people, you know, like corporations and so on that developed the Apple phone and things like that, but they're very much dependent upon government involvement. And that kind of ties in with corporations and limited liability corporations and investment plans and so on that government has to sponsor and develop and
Enforce contracts.
enforce contracts and things like that, yeah. There was an interesting thought about passports, you know, the importance of passports as a development. Used to, for quite a while, they weren't thinking that passports were that important, but then I think passports were originally like a king of a territory or a leader of a territory would write just a little paper thing that you'd take with you if you were going somewhere else, and you could walk into a town and say, you know, my leader approved that I come here and ask that you treat me fairly and so on, and those are original passports. And then as more and more people traveled, it got to be less and less important. Maybe special people for a special purpose might get a letter from their king, but not everybody was getting it. But then they started developing more, actually, I think the British started redeveloping it because so many people were trying to get into England and all these different things. They're trying to restrict it a bit more than prior to that, too. Okay, any?
How often do you see a movie, like a Second World War movie? How often do you see it's like a Second World War movie, and the Germans will stop somebody, show me your papers?
Yeah, yeah. Yeah, the papers laws that were there, right?
Speaking of World War II, my dear husband, who's running the AV in the back, told his sister that color was invented for the purpose of helping our soldiers win World War II. So maybe color didn't even exist prior to that. Yeah.
Do you have a retort at all, Dave, or are you just going to let that lie?
Right, there were no colors on TV or movies prior to that. So.
I think there's a comment in the back.
Coughing my through it. I'm not sick. I just have a tickle in my throat. So, since you brought up color, and someone brought up engineering earlier, I thought I'd do an engineering art plug. The invention of, or the discovery, depending on how you look at it, of the mathematical formula for perspective, linear perspective.
And when was that?
There's also an atmospheric perspective, but that's something different. That was invented, if you want to call it invention, early 1400s. Brunicelli, I think his first name was Filippo Brunicelli, and he actually developed it for engineering, but artists picked it up very quickly because in the 1400s, engineers were artists and artists were engineers often, and that influenced the way people saw two dimensions. I believe I remember reading that Greeks and Romans understood perspective, but it was lost in the mists of the Middle Ages, although certainly cathedral builders knew something about the mathematics of perspective. But sometimes when people say it was lost during the Middle Ages, that just means that the guilds were extremely private and didn't allow the information outside the guild. And so it's been lost in the sense that it was kept private. And if the records weren't kept, then, it's lost now. But that was a really important invention for lots of different reasons. For instance, based on some research with early isolated tribes, people in the tribe couldn't interpret 3 dimensions in drawing because they had never seen it before. And so because of that, there's some speculation if we haven't, as a culture, grown up with seeing perspective, by this point, it'd be tough for us to understand photographs. So we'd have to learn how to understand photographs. So anyway, there's a lot of impact that, you might not think about.
Yeah, that's interesting. I know, I remember, my art history class, and they were showing the Byzantine drawings and the triptychs and things like that, and all the Ottoman drawings, and they were all kind of just very face-on and no real perspective or depth to them at all. And then I think Giotto was important on some of that too, and yeah.
Through the Middle Ages, there's a lot of weird perspective.
Yeah.
Backwards perspective, things like that. Trying to figure out
How to do it, yeah. Well, and talking about architecture and so on, I'll go into another one that to me is pretty amazing. Just the fact that elevators, which had been around, for example, I think Archimedes had an elevator years in ancient Greek times. Louis XV had one, but that was for a very important purpose. It was in the Palace of Versailles, and his mistress was kept on a different floor, and he could go in through a door and down the elevator to his mistress, or she could come up and visit him, however, too. But those were all kind of hand operated, and can you imagine the job of being the elevator operator for Louis XV, just waiting for the time, and you better be ready when the time comes.
Yeah, is it Louis or is it the mistress? Because, yeah.
And, but actually, a fellow named Otis was in the 1853 World's Fair in New York City, and he developed not just the elevator, but not the elevator, but the elevator brake, right? The safety elevator. And he stood up, they'd lift this elevator up, and he was up on the top of this elevator, 5 stories up in the air, and they'd have a henchman there with a big axe. And he'd take a swing and he'd cut the rope, you know, and the elevator would shudder, but it would stay right there. And so that made his, you know, it was a good marketing technique, and Otis elevators became very popular and big. But up until that, you know, no one would really ride an elevator. People would not ride an elevator unless you were Louis XV's mistress, maybe.
Just going a floor or two.
Right.
Yeah.
But yeah, and it changed architecture in so many ways. What used to be on the 4th and 5th floors of buildings, servants' quarters, right? The place where you stuffed the old mad ant, right? You know, maybe storage of everything was up there and so on too. But once there were elevators, they became penthouse apartments, right? And loft apartments, right? And, you know, places with magnificent views and so on. So it changed the whole development of architecture in that way. And then when you think about really what elevators have done, it's just combined with this whole broad system, kind of where Dave was going a little bit too, a broad system of urban design, you know, and modern, here's some of the things I was talking about, yeah. The elevator brake, and it basically turned city landscapes on their head, literally. You could efficiently house many more people, right? So this broad system of urban design, modern glass skyscrapers came up, and it was a combination of a bunch of different inventions, really. Air conditioning made them inhabitable, right? The fact of even early systems of air conditioning made them not overheat. Steel and reinforced concrete made them able to even be built. They weren't possible to go to the heights that they did until the 20s or so. Elevators made them accessible to people, right? And all of a sudden, mass public transportation made them reachable so that you could get to them, get away from them, get to wherever else you wanted to go, and you could have that many people in them. Actually, if you think of it, an elevator is one of the most efficient mass public transportation systems we have, right? People get mad if you wait more than 20 seconds for an elevator. They'll wait 5 minutes, 10 minutes for a train, right? But, you know, 20 seconds, like, what's going on? That's basically why they put mirrors in elevator lobbies, because people have something to do then for 20, 30 seconds. It's true, that was a design decision. So this made this densely packed vertical structure and put it next to a subway system where you can get people in and out and up and down and around to different places. You can do all these different things. It's actually one of the most ecologically green, from a civil engineering standpoint, structures, methods of housing people that there are. It's a really green urban environment. There's low rates of energy use per person. There's accessibility to a lot of different things. You can get pretty easily to shops and different things like that, right? So much less use of energy than in what we have out here in the suburbs, and what there are even in, you know, in small villages in Africa or something like that. They use more energy per person often than is used in a massive building like that. Okay. Anyways, those are some of the ones I thought that was very fun. This is Tim Harford. How many people are familiar with Tim Harford? He does a podcast that's called Cautionary Tales. He's an Englishman. He's written a book you probably know, you may know, The Undercover Economist. He wrote for a lot of magazines and things like that, and so he writes kind of countercultural stuff, almost like a Freakonomics kind of attitude about things. But if you can get his podcast, I listen to it religiously. It's called Cautionary Tales, and he tells stories of different methods that people tried to do things and the results that came out of it, and sometimes from an economic viewpoint. He's got a great one about the guy that developed, what is the machine you ride around on that everyone thought was going to change the world? Segways.
Segway,
Yeah. He does a great talk about the guy. There are two inventors. One invented the Segway and came up with this whole method of publicizing it and he sent it to different people to get them to respond, and people thought, I think Bezos said it was going to change the world and everything. And then he compares it to another guy who worked and he built, he was a welder, and he built a collapsible kind of container that he thought that might make it easier for him, because he was welding things that went in streams that were eroding, and they could put rocks and things in there. And all of a sudden it found all different ways to be used in the world. Military people use it. They can build a fort, around their people in a matter of minutes by just a bulldozer and this openable kind of metal chain thing. And he became rich out of that. And the guy that had Segway had all this stuff that people said was going to change the world. Your postman's going to come up on a Segway, right? Everybody's going to have Segways to get around. And it never really took off. And actually the guy that made these just little metal containers metal wire containers that put rocks in, he actually ended up buying Segway.
Didn't the inventor of Segway die from falling while on a Segway? Fell off a precipice or something?
I think actually the guy that died off a cliff, he was backing up to let a person pass him on his, I think it was the guy that actually bought the Segway. Yeah, he was the owner of Segway, but not the inventor.
Okay.
The guy that made this wonderful method of putting rocks in a cage.
I was thinking about your elevator thing, and the whole thing has its ups and downs.
Yeah. Nark, nark, nark.
It's a very uplifting story. Yeah.
It was an uplifting story, Scott says. Yeah. All right. Well, any other topics or concerns?
When I saw up there air conditioning, it brought back memories. I've actually been in theaters where they had an ice room, where they had fans blowing across the ice to cool the
Blocks
theater.
of ice, yeah.
Yeah, and before that, obviously, people would go out and cut ice and refrigeration in general. Yeah, it was one of the major uses of the ice process was in railroad cars to keep the kegs of beer cool so they could be transported from wherever they were made to wherever they wanted.
Refrigerated trucking, yeah, big thing. Changed how we eat and everything. My dad always called it an icebox, right? That's because he grew up in Milwaukee in the 20s, and so, yeah.
I'm not that old, but I do remember seeing on TV.
Yeah, but he called it an icebox. He had an icebox, yeah, he did as well, too. Yeah, interesting stuff. I know that coming up in 2 weeks, you're going to be talking about another astronomical kind of...
Yeah, I want to continue a theme about, Mike really started it with his planetary exploration and a survey of our solar system, and that led me to thinking about different topics. I talked last time about the Drake equation, and I thought I'd follow that up with a couple more. So the first one's going to be on the Fermi paradox. Anybody familiar with what that means? So it'll be new to several of you. And then I want to talk eventually this year about the prospects of terraforming Mars and a couple other things, all in that same sort of theme about the universe outside of us and how we might get there or what we might expect to find or do.
Okay, great. And Joanne, I know you asked to mention something that you wanted to talk about as well, too. So that'll be 2 weeks from now, Scott's.
Hi, I'm Joanne Reed, and I wanted to mention that on the third Thursday of every month, we have what is now called the Humanist Luncheon. It used to be the Philosopher's Luncheon, but we never discussed philosophy, really.
People felt too much
it was,
pressure,
It was a
right?
bull session. And the whole idea was just to get together with people like ourselves who just talk and just be with other people. And I'm looking at the next 4 years as being problematic. Is that a good word? I think I need people who are more like me, so I can get together and talk about those things without fear of the Nazis coming in and stormtroopering. So what do we have? We have again, the third Thursday of the month. We go to Stevens Restaurant, which is on 63rd Street, just off of 355, 1 block east of 355. And we gather at 1 o'clock and we just have some food, sit around, talk, and relax a little bit. So I invite you to come, but I don't know how to get in touch with you. So I wanted to hand around a thingy so that you can put in your name and your email address so that I can get in touch with you. Otherwise, I have to stand at the top of my building and go, hello, and it doesn't work. So I'm going to hand a doohickey around, and if you want to join us, come on down.
Maybe they can come up and sign up, since we're at the end of our program, so. All right.
And Scott, you generally go to that, right?
I don't,
Okay.
because it's in the middle of my workday.
Yeah.
I haven't retired yet.
Okay. All right, so yeah, please sign up, and those have been interesting conversations. Thursday at 1, third Thursday of the month. So 2 weeks from now is Scott. 2 weeks from that will be Mike Albrow talking about physics and his topics that he wanted to bring up. You and I have to talk about exactly who's doing the third Thursday. You probably want to use it, and I'm fine with that. So
Okay.
we'll talk about that more. And so thanks a lot for coming. I really enjoyed it. I thought there was a lot of interesting, wide-ranging concept. I was trying to figure, do you focus it in and bring it in on something? But then you can't talk shit like Dave wants to if you don't keep it wide open. So,
All right.
so thanks a lot. Appreciate you coming in. Have a great new year.